All right, section 7.4, just so that you guys know, we're going to do it in one day. So it's not going to take very long. It's only one key concept in section 4, just so that you are aware of it. There is no graphing involved today. There's none of that. We're just doing one particular thing. So the first thing that I have to ask you is, how do you do 4/5 plus 3/5? Okay, first and foremost, if I'm a person that is adding and subtracting fractions for the very first time, if you told me to add straight across, like I heard 3 of you say, I should get 7/10, which is not accurate. Okay? So, what needs to happen? First of all, you said keep the denominator the same. Okay, and I heard you guys retract that and say that next. What's the major rule when it comes to adding and subtracting fractions? The denominator has to be the same. If it's not the same, what do? Change it. Make it. How do you make it? How do you find a common denominator? Something that they go into. Find the least common denominator, least common multiple between the top and the bottom. Or the two bottoms, I mean. Okay? What do you think of that so far? Do they have common denominators? That's 2 divided by 21x. Do they have common denominators? Yes. So therefore, according to what you just told me, we're going to add the tops. What's 5 plus 2? 7. What do I do at the bottom? Keep it the same. Then, after you've added them together, if there's an opportunity to reduce the fraction, you always have to try. Is there a number that can go into both 7 and 21x? Not 3. 3 does not go into 7. 7 goes in there, right? What's 7 divided by 7? 1. What's 21 divided by 7? There's where the 3 is. If you do not reduce your fractions, you will get it wrong. Just so you know this. Okay? If you do not reduce your fractions, you will get it wrong.
Will we get it wrong if we don't reduce our fractions?
Yes. Are the denominators the same?
Yes.
Yes. So now, go straight across. What's 4x minus 3? It would just be 4x minus 3 because they are not like terms. Good job, Kylie. So they are not like terms, so the 4x and the 3 do not get reduced down to 1x. Okay? Now, the bottom was still x minus 5. Is there anything I can reduce? Okay, now the first thing that I heard someone whisper to me and say, yes, the x's, and now I get to say no. That doesn't work that way. When you have an x minus 5 on the bottom and a 4x minus 3 on the top, it has to be the same group. It has to be identical. Okay, it has to be like an x minus 5 and an x minus 5 in order for you to cancel it. As soon as you throw adding and subtracting in there between variables, they need to be identical in order for you to cancel them out. The x's cannot. The bottom, x minus 5, the x is married to that minus 5. So therefore, it has to be an x minus 5 on the top and an x minus 5 on the bottom in order for you to cancel. Same with the x on the top. 4x minus 3 has to be a 4x minus 3 in the top and a 4x minus 3 in the bottom. If it's not there, you can't get rid of it. So therefore, this is your answer. Okay? Like, give me a chance. Like, give me a chance. I'm not done yet. Okay, are the denominators the same? Yeah. What's 2x plus 2? Or sorry, 2x squared plus 2. 2x squared plus 2. Over x squared plus 1. Awesome. Can you reduce that? Yes. Here's how. On the top, is there anything I can factor out? 2. I can take a 2 out, which then gives me this. 2 parentheses x squared plus 1 over x squared plus 1. When you take a 2 out of 2, you get 1 in place. Like for instance, the other day, Allie happened to be gone. You know, I saw her later on, like an hour later, but she was gone in class the other day. So therefore, we saved her spot for her though, because we missed her so much. Okay? The 1 is like a spot holder. That's what it does. And I don't know if you guys not everybody gets that. When you take a 2 out of 2, you don't get nothing. You get a spot holder. So that way when they do return, everybody's happy. Okay? So, now, look at, is there anything that matches the same on the top and the bottom? Yes. Now, start hacking away. And what do you have left? 2. You have a big old deuce. Right. Okay? Now, the question came up by somebody up here that said, is the bottoms ever going to be different? Probably not is the, but are the bottoms ever going to be different? Yes, they are. Let's see here. Let's give you 3 over 4x minus 1 over 7. Okay, my first question to you. Are the bottoms the same? No. No. Make them. So in order to get the common denominator, now notice one thing that I said there is I said a common denominator. I did not say the smallest common denominator necessarily. I just said a common denominator. Sometimes it helps if you just multiply the two pieces together. So if I have 4x and I have a 7, first of all, what's the smallest number that both 4 and 7 go into? 28. Well, that was easy because all I had to do was multiply 4 times 7. Don't forget, the x is also a part of it. Now, what you have to do is you have to look at this and say to yourself, self, what did I multiply 4x by to give me 28x? 7. Right. So then if I multiply the bottom by 7, what else do you have to do? The top by 7, yeah. And what's 3 times 7? 21. Now, for the right-hand side, what times 7 gives me 28x? And x. What's 1 times 4x? Yay. Now, adding straight across, because I do have common denominators right now, what's 21 minus 4x? 21 minus 4x. You cannot combine those together because one's got an x and one doesn't. What about the bottom? Now, again, this goes back to the last concept that we just talked about. Do they all have an x? No. So I can't take out an x. Can they all be divisible by the same number? No. 7 doesn't go into all of them. 4 doesn't go into all of them. So you have then simplified it as much as you can. That's your answer. X over x squared minus x minus 12 plus 5 over 12x minus 48. So I've ramped it up quite a bit in from one to the next. Now, for this particular thing, what I don't want you to do, look, the last one we could have got away with just multiplying them together, and we could do that here too, but if you multiply these two pieces together, you're going to have a big, ginormous thing on the top. I don't think you want a big, ginormous thing on the top. So, therefore, the easiest way to do this to see what you have to work with is factor the bottoms first. What times what gives me x squared? X and x. What times what gives me negative 12 but adds up to be negative 1? Okay, let's back up the train here. What times what gives me 12? 4 and 3, 6 and 2, and 1 and 12. How am I going to make that make a negative 1? Minus 4, positive 3. So what I've done is I've rewritten the bottom to be this factored group. Now do the same thing for the next one. But remember, when you factor, the easiest thing to do first would be, is there anything you can take out? You could take out a 12. Sorry, I channeled my inner Canadian for that. So when I take out a 12, what do I have left? X minus 4. Now, I want you to see with your eyes, is there anything that the one fraction shares with the second fraction? Right. So if you would have just multiplied them together, you would have had 2 of those. That's overkill. Now, here's how you find the common denominator between two fractions like this. Okay? Or at least how I do it. What I want you to do is take the left-hand fraction first and write down both bottoms. X minus 4 times x plus 3. If it's in the first fraction, it definitely needs to be in the end result. Right? So the first thing that I'm going to do is I'm going to write down all the pieces, Mises, from the first fraction. Okay? Now I'm going to jump over to the next fraction, and I'm going to write down any piece that I have not used yet. So from the second fraction, what piece have I not used yet? The 12. Where do you want to put said 12? In the front of those two parentheses or at the back end? Front? Okay, me too. But here's the little thing. Doesn't matter. Because it's all multiplication. So all I did was I jumped over to here, and you guys told me 12 was the new part. Because you already wrote down x minus 4. So why write it twice? So then I put a 12 in there. Guess what? That new bottom down there, have you accounted for all the pieces? Yeah. Guess what your common denominator is? 12 times x minus 4 times x plus 3. Now, here's something that will benefit you. I'm not going to require you to multiply that back out. Please don't. There's a reason. Because when I go to doing my next step, if I do factor it after I add it, if I notice there's a group that matches with the group on the bottom, then I can cancel it. But if you have it all multiplied out, then you got to refactor it back. Just don't. You've already taken the time to do that. So now, from the top set to the bottom set on the first fraction, What's different? The 12. So I would have had to multiply it by 12. And what I do to the bottom, I got to do to the top. What's 12 times x? 12x. Good. Now, for the second fraction, what's different? From here to here, what's the new part? Good. So if I multiply it to the bottom, then I also have to do it to the top. What's 5 times x plus 3? 5x plus 15. You distribute that through. Absolutely. We have a common denominator. So now the last thing I have to do is combine like terms for the top. What's 12x plus 5x? 17x plus 15. All over 12 times x minus 4 times x plus 3. Can you factor the top? Can I take anything out of a 17x and a 15? No. So guess what?
You're done.
You're done. That's your answer. If there would have been something that I could have factored out of the top and it would have matched with something on the bottom, then cancel it out. Have you ever played concentration before? If you say no, you're lying because you've had it when you were a kid. I know you have. Like you probably had Mickey Mouse once. You had to match the different characters. Okay? Memory is another thing. Concentration and memory are the same thing. Okay? If something matches from the top and the bottom, you cancel it out. If they don't, you're done. So are you done with this problem? Yeah. That's about as hard as they're going to get. Do you want me to do another one? All it is adding and subtracting today. That's the only two operations you have. So, on page 388, 4 through 8 evens, and 21 to 25.